Today, we're going to talk about something really fascinating. We're going on a journey from designing just one helpful AI tool all the way to managing a whole ecosystem of AI out in the real world. It's like we're zooming in on the tiny details of a user interface and then pulling all the way back to see the giant challenge of running what's basically an entire AI factory. So, how are we going to tackle this? Well, we're going to start small with a really frustrating task that software architects have to deal with. Then we'll look at how a clever AI assistant can come to the rescue. And that's where we uncover this surprising dilemma. You know, that classic battle between human control and full automation. And then we'll zoom out to see how that one little problem is connected to the massive challenge of managing AI at scale. Okay, let's dive in with a problem that, well, if you're in tech, you'll probably feel this one, even if you don't know what it's called. It's that kind of work that takes a ton of skill, but is just so tedious. It's just begging for a better way to get it done. I mean, think about it for a second. We always hear these big stories about AI coming for creative jobs or super complex jobs, right? But what if its first big win, its most immediate impact, is just getting rid of the most boring parts of our jobs? You know, the repetitive, mind-numbing stuff that even the experts hate doing. And that brings us to something called software architecture consistency checking, or SAC for short. Okay, so imagine you're a software architect. You've designed this beautiful, elegant blueprint for how a massive piece of software is supposed to work. Your job now? Go through thousands and thousands of lines of code, one by one, and manually check if the code actually matches your blueprint. It is every bit as tedious and manual as it sounds. It's a huge pain point. So, faced with this kind of mind-numbing work, a team of researchers decided there has to be a better way. They built an AI-powered assistant to tackle the problem head-on, and its name is InMap. What you're looking at here is basically the engine that makes InMap work. It starts by taking all that raw source code and just cleans it up, getting rid of all the junk. Then it uses that clean code to intelligently hunt for matches against the official architectural blueprint. But the real magic, the part that saves all the time, is that final step. It just presents the architect with a simple choice. Here's what I found. Do you accept or reject my recommendations? It turns hours, maybe even days of tedious work into a quick, simple review. Okay, so once you've built a cool AI tool like this, you hit a really fundamental design question. How much control do you give the human, and how much do you let the AI just handle on its own? And that's not just a tech question, right? It's a deeply human one. And to dig into this, the researchers actually built two different versions of InMap. The first one, the automated design, was all about speed. You know, fewer clicks, faster results, just get it done. The other one, the human-in-the-loop design, was the complete opposite. It gave the architect way more control and insight at every single step. Now, users felt that one was more robust, but it was also slower. So you've got this classic conflict, right? Do you want pure, raw efficiency, or do you want total control? And this is where things get really interesting. Because the study found something completely unexpected. The common wisdom, right, is that for us to trust an AI, it has to be basically perfect. It has to be super reliable. But that's not what they found at all. The experts in the study actually preferred the faster, automated version, even though it wasn't flawless. They valued the efficiency more. And that just completely flips our usual ideas about what it takes to build trust between a person and an AI. All right, so we've just looked really closely at the design challenges for one single AI tool. But now it's time to zoom out, way out. What happens when a company isn't just using one tool, but hundreds, maybe even thousands of AI models all running at the same time? The problem gets a whole lot bigger and a whole lot more complex. And this is where the whole game changes. We're not just talking about designing a nice user interface anymore. This is an industrial-scale engineering problem. How on earth do you make sure that all of those models are reliable, efficient, and are actually, doing what you built them to do? Well, the answer to that massive question has a name: MLOps. The easiest way to think about it is it's like DevOps. DevOps completely changed how we build and ship regular software, right? MLOps is doing that exact same thing, but for machine learning. It's a whole set of practices that brings together machine learning, data engineering, and, well, operations to manage the entire life of an AI model, from just an idea on a whiteboard all the way to a critical tool that the business depends on. So why is everyone talking about this now? Why is MLOps suddenly so critical for businesses? Well, the numbers. The numbers tell a pretty scary story about what it's really like trying to get AI working today. Get this, a staggering 88%. That's the number of corporate AI projects that get stuck in the testing phase. They just never make it out of the lab and into the real world where they can actually do some good. This is exactly the problem MLOps was created to solve. It's about taking AI from a cool science experiment and turning it into a reliable, repeatable part of the business. And MLOps tackles this with a really clear set of goals. It's all about building a proper assembly line for AI. You want to automate deployment to make it fast and repeatable. You need to make sure every model can be reproduced and, crucially, monitored for problems. And of course, you have to make sure everything is scalable and compliant. Basically, MLOps provides the playbook, the rules of the road, so that data scientists and engineers can actually work together and get stuff done. It's how you run a real AI factory. Okay, so now let's bring it all back together. We've had our deep dive into one specific tool, and we've had our super wide-angle view of the whole AI factory. What's the big takeaway when you put these two stories together? Here's the thing. The secret to making AI actually work isn't just about building smarter and smarter algorithms. It's really about a partnership. You absolutely need that thoughtful, human-centered design we saw with the Nmap tool. And you need the robust, scalable engineering that MLOps brings to the table. You have to have both. Because if you don't, you either end up with tools that nobody trusts or you have powerful models that are stuck in the lab forever. And all of this leaves us with one last big question to think about. As these AI systems get more and more powerful, more capable, more autonomous, what are we going to want? Are we going to be like those architects in the study and start to prefer pure efficiency over careful oversight? Are we going to demand more control, or are we going to be happy to give up control and have less? That, right there, is the core dilemma at the heart of our future partnership with AI.